Hello, I'm Svetlin Nakov from SoftUni, the software university. I'm here for the next part of my free Java Basics coding tutorial, which is a series of video lessons with hands-on coding exercises for absolute beginners. If you missed the previous parts, please review them first to catch up. In this lesson, I will talk about variables and data types such as strings, integer numbers, floating point numbers, booleans, and others. Also statements which define the commands in the program, and the most used arithmetic operators like plus, minus, multiply, divide and remainder, and the expressions in Java, or how to combine operators with values and functions to implement a calculation. As usually, I will show you how to solve several coding problems and how to submit your solution in the Judge system for automated grading. Don't skip the coding exercises at the end of these lessons. They give you practical skills and coding experience. To learn coding, you should code. That's it. Let's start. Let's learn how to use data and calculations in Java. Let's start with variables. In programming, variables are used to store and process data in the computer memory. Variables are named memory areas which hold data of certain type, like number or text or something else. Let's learn more about them now. So how does computing works generally? Computers are machines, computational machines that process data. So both program instructions and data are stored in the computer memory. Program instructions are stored in some location of the computer memory, and data is stored in another location in the computer memory, and data is split into places which have names and which hold certain values. Data in programming is stored using variables, which means that each variable may have a name and may have a value and location in the memory, just like the walkers in the dressing room. So walkers in the dressing room have names and have also some kind of labels or numbering or some way to locate and differentiate between them. So in computer memory, we may have a variable which holds some data and has some name, and accessing the by the name gives us the value stored in the variable. Just like opening a locker with certain names gives the properties and belongings to someone who uses this locker. So variables have names and hold something, and they have location in the computer memory, and we can consider a computer memory just like a series of lockers which hold something. So a variable is a container for information. It's a named area of the computer memory which holds something. The data can be read and can be changed at any time. This is where the RAM comes from, RAM, Random Access Memory, RAM. So variables provide means for storing data, so you can change or put something in a place in a variable in the computer memory. You can retrieve the data which is previously stored in a variable, or you can modify existing previously stored data. So variables in programming are characterized by name. For example, the name could be age, or student name, or size, or list of students, or something like this. It may have type. Variables usually have type. In some languages, they don't have type, but the type depends on the value, and they have value. So, for example, we can have a variable called age, which is of type int, integer value, and it holds a value of 25. Or we can have a variable called name, which is of type string or text, and it holds the value Peter. And we can have a variable named size, which is of size of type double decimal number with double precision, and it may hold a value like 3.50. So defining a variable in Java usually comes together with initialization, and it consists of this. We declare the data type, then the variable name, and then we assign a value. So before going further, let's look how this works in the practice. I will create a new project which will be called, for example, variables, for example, because the name of the project should answer the question what's inside. So this is my project. It holds the source code with some main class, and here I can put some variables, for example, int x equals 25, and I can print this variable x, and I can define, and this works as usually. You already know how this works. It will print 25 on the console. But I can also declare more variables, just like string name, and I can assign it later. For example, name equals to Peter. Now I can print the name, and later I can assign in the name another person, for example, Mariah, and I can print the name again. So this is how this works. It will print first 25, then Peter, then Mariah. So if I use the debugger and say debug main after putting this red breakpoint, we can see the variables here. So variables usually have some ID, some label, like labels in the locker or some location in the memory. It's not necessary to be a location, but it's a unique identifier which maps to unique location in the memory. So I have now this x25 and name, which is Peter, and also name is now Mariah. It's a complex object which holds array of 5 bytes at certain location 811, and this is another location 808. By the way, this string args is also a variable which is used to pass parameters to your console-based program. So this is how it works. Variables hold values, and these values after declaration can be changed. And you can also use, instead of int, you can use var, and then the type of the variable is identified by the compiler from the right part here. So here x will be of type int. You can check this. It is int, but it's not clear that this is int. But we can, if we say 25.0, this will be x will be of type double. Let me show you this. It is of type double, value of a primitive type double, and this is a value of type array. We will learn about arrays later. So this is what I wanted to show you about variables. They have name, type, and may hold value of this type. In Java, variables cannot change their name at runtime. For example, if we have x, we cannot say x equals to hello. This may work in Python and JavaScript, but here we have a variable of type double, because this is double, and this var assumes the type from the value. But we try to assign a string, and these types are not directly compatible, so this will give us an error. This is how variables work in Java. They cannot change their type. And in some languages, variables can change their types, like Python and JavaScript, in the so-called scripting languages. So defining variable in Java usually comes together with initialization, and you define the data type, the variable name, and the variable value. And of course, you cannot use the same name twice, because this is ambiguous. Variable x is already defined, so the compiler doesn't know if you want to use this x or this x. So names should be unique. Okay, that's about the variables. Let's continue. In this section, I'll give you a brief explanation of data types in programming and how they work in Java. I will mention the number types like int and double, the text type or string, and the character type char and the boolean type. And of course, I will demonstrate you these types in live coding examples. So data types are related to what kind of data we store in a variable. Variables always store values of certain types. Variables in Java have type and values also have type. So we can assign in a variable of certain type a value of the same type or compatible type. For example, in a variable of type double, we can assign either double or int, but we cannot assign string. So variables can be numbers, letters, strings, texts, it can be date or color or picture or list or of customers, for example, or video or some kind of data or objects. So data types in Java can be primitive types like int, float, double, boolean, or some more complex types like string, like array, like list. We'll mention all of them. So data types can be, one of the simplest types is int. It holds integers like 1, 2, 3. Let me show you. So if I have int x equals 25 and I can print this number here, and this works as expected. Strings ints can have a range. For example, you cannot store this because this is out of range, it's too large, but basically the int range is enough for most numbers. It's between -2 billions to 2 billions, nearly. If you want to have bigger ranges, you may use long integer like this, and it may have bigger scope, but you should put L suffix here to explain the compiler that this is a long value, not int value. So I can run this program and it will work correctly. I can even add 1 and this will work with 5 at the end. So double is a floating point number, and if we have double value, we can have 3.5, for example, and when we print it, it will be printed as expected. We may have more digits after the decimal point, and it can be positive or negative. It can be close to 0, for example, like this one, for example. And sometimes double can make some incorrect calculations, but we'll talk about this later in the next course, Java Foundations. So here we see that this is printed, this number looks strange. It is printed in the so-called scientific notation, which means that this number is multiplied by 10 raised to the power of 7 by 10 to the power of 7. This means -7 means that we have this number divided to the 10 to the power of 7. -7 means divide by 7, or +7 means multiply by 7. So this is the so-called scientific notation. It is used for very large numbers or numbers which are very close to 0, like this one. It will just change the magnitude of this number, not the number itself. So this allows us to keep in double very small numbers, like very close to 0 numbers like this. So another type is Boolean. If we have Boolean x equals, it can be either true or false and nothing else. True or false. It can never be something different. You cannot assign, for example, -5 it's impossible, and it's either true or false. Char holds a symbol, for example, character, for example, like A, the letter A, you can see this, or the letter, for example, dollar, and it's always typed in single quotes like this. And if we use x plus 1, this will give the next letter after this. But it is as a number, because char can be transferred to a number by the plus sign. So if I make a cast like this, I can get the next number after this. For example, after A, the next letter will be B. This is how this works. So I can print X and the next letter after X. This is a kind of this consists of typecasting and expression calculation. So if I have, we can have letters from different alphabets. For example, this letter is from the Cyrillic alphabet. It's called Ya in Russia and in Bulgaria. And we may have other letters like this one, for example, this question mark. And the next is this one. And we may have emoticons and other, let me try to find something. It's not always easy to find such a non-letter. Also, letters cannot be empty. They can hold space, but they cannot be empty. Strings can be empty. Strings are sequences of letters. For example, hello, and they should be put in double quotes. And it's string with capital because this is a class. This is not primitive type, it's a class. And you cannot do this calculation like this, but you can print the string. We'll have another lesson devoted to strings in the next Java Foundations training course, but be patient. So we can work with letters like this. We can concatenate with strings or with other text. And also strings can also hold empty value like this, or strings can be null. Null means that there is nothing in the string. X equals to X plus hello. Now, because it is null, it will tell null, it will append null and hello, because this is how it works. It's in most cases it is good to hold empty string if you want to have a value, but it is possible for it to be empty. And also we can have some strings like this. I'll show you, for example, Salam alaikum. Sorry if it is not the correct. Assalamu alaikum. Maybe this is the correct pronunciation. Sorry, I don't speak Arabian, but basically you can hold these letters, and they also work from right to left. So see, I move the cursor on the left, on the right, right, and see what happens. It works. It may run, sometimes it runs the opposite direction. No, the direction here is given. But basically you can use other languages like Arabic, like Chinese, Korean, etc. Okay, so this is how strings work, and strings hold sequence of characters. They can be empty, 0, or can be several letters. They usually hold some text. For example, the username of a person, or bio of the person or website URL. All these are examples of string. Data types define ranges of values with similar characteristics. For example, the int type is from -2 billions until 2 billions. I believe I'll find this in the documentation somewhere, and this is the max value, but this is in a hexadecimal format. It is like this: -2 raised to the power of 31, and this is 2 raised to the power of 31 minus 1. This is the maximum value. So you can find it in internet, for example, Java int range, and this is the range of Java of strings. It is given somewhere from this until this. Okay, so data types are characterized by three things: name, size, and default value in Java. In Java, for example, the data type name can be boolean, int, string, and if it is with a small letter, it is built-in or a primitive type, and if it is with a capital letter like this string, it is a class, or it is a complex object. It's not primitive. Primitive types stay in the stack, and complex types stay in the heap, and we'll discuss this later. Some are passed by value, others by reference, but we'll talk about this later, as I already explained. And they have size, how many bytes in the memory they use. For example, int uses 4 bytes, and the type long uses 8 bytes, and the type string uses variable number of bytes. For example, it uses 4 bytes for the length, plus 2 multiplied by the number of letters to hold the letters or the characters inside the string. And they have default value, which means that if you don't explicitly assign a value, the value will be 0 for the primitive types, false for booleans, and also no for strings. In programming, statements hold commands in the computer programs, a step from the program's algorithm. Let's talk more about them. Statements are actions that program takes. They are expressed as statements in the programming languages such as Java or Python, and we may have many kinds of statements, but basic statements, or we can call them actions or commands, they include some basic operations which you can make in your program. For example, declaring a variable, you can say int counter, which declares a simple variable. I will make an example, int counter. So if I just declare the variable here, I cannot directly print it because it's not initialized, but this is another story. So I can have another command or statement which says count equals, please assign to the counter the value of 5, and finally print it. So this is a statement, this is also a statement, and this is also a statement. These are simple statements: declaring a variable, assigning a value, or declaring and initializing a value on the same line, like this, which is quite more readable and quite more efficient. You type less code. So printing a value is also a kind of statement. It's a function call statement or method call statement. And modifying a value, like counter plus plus, for example, is also a statement. Or we can say that counter equals to 2 times counter plus 1. For example, we can put some spacing to improve the readability, but basically this is a statement, declaration statement, this is another statement, calculation of expression plus assignment, and this is a printing statement. We call the function println and we pass a parameter what to print to this function. And this is another example, sum equals to a plus b. These are called simple or basic statements, very basic actions or commands in your program. In programming, we may have more complex statements, like, for example, the if-else statement. For example, I can say if counter equals 5, then print the word 5. Otherwise, print as out the number, it is not 5, for example. Okay, and when I run this, it will tell me it's 5. If it is 15, it will not be 5, and this complex statement will give me something. So I have a complex statement. This is the first statement, and this is the complex statement. It consists of if, expression, another statement, else, another statement. So a statement can internally hold other statements inside, just like this one. This method main holds a sequence of statements. This is the first statement, and this is the second statement. We may have third statement here, for example, like this. Okay, so another statement is the loop statement. It's more complex because we repeat a piece of code like this. For example, I can say while counter is bigger than 0, please execute these statements. Print the counter and decrement the counter. So this is the first statement. This is the second statement. It consists of while loop, which checks a condition, and if this condition is true, it executes this first statement, then the second statement, and repeats this again. So this will print the numbers from 15 down to 1 in a loop. This is called loop statement. We'll have a separate lesson about if-else and conditional statements and more complex conditional statements, and also we'll have another lesson about loops. And another more complex statement, as an example, is the method definition statement. So we can do like this: static with, assume that we always put static, someday we'll explain why, but this is the return type int or maybe long sum of int a and int p, and this return a plus p. So this is a method declaration statement, a method sum which takes two input variables a and p and returns their sum. In mathematics it is called a function which sums two numbers. So I can say that int sum equals to sum of 3 plus 5, or maybe it will be s, long s, and I will print s. So this is the first statement. Please, just like we call system out println, we can call sum, and this sum invokes this method. So we have this declaration, this is the first statement, and this is the second statement, and this is another statement which defines a function which holds sequence of statements. Currently we have only one statement, return a plus b. and it works as expected. This is how we use the method called statements, and there are many other statements like the switch case statement, like the other whoop statements, or class declaration statements, or interface declaration statements, and many others. So statements are like sentences in the natural language. In the natural language, if we want to write an essay, we put a sequence of sentences. In programming, if we want to write a program or procedure, we use a sequence of statements. So it's very similar. Programming languages are similar to natural languages, and we have simple statements or basic statements and complex statements like these ones. Let's talk a little bit about the operators in Java, and more precisely about the arithmetic operators, which implement arithmetic calculations. I will explain the operator plus for adding numbers, minus for subtracting numbers, asterisk for multiplying numbers, and slash for dividing numbers, and percentage for calculating the remainder of division, the module. So let's start with adding numbers, which is the simplest operation. It is implemented through the operator plus, like this. So if we have two variables, a holding 5 and b holding 7, we can say please calculate the sum of a plus b, and store this in the sum variable and print it, and it will be 12. I will demonstrate this here just to clean up my code, to empty some space. And int a equals 5, int b equals 7, so int sum equals a plus b. This plus means sum of two numbers. If we have numbers, if we have something which is not a number, it may mean something different. And when I print the sum, it will be, of course, as expected, 12. Okay, so subtracting numbers is done by the operator minus, and it works very similarly. If we have 15 minus 7, it will be 8. And it works, of course, with negative numbers. 5 minus 7 will be minus 2, because this is how mathematics works. And nothing strange or interesting here. It also works not only for ints, but also for doubles. If we have double, and the result should also be used double. You cannot store the difference between two doubles in a normal int, but you can subtract int from double. So a is 5.34 minus 7, which is int. This operation is valid because this will be first transformed to double like this, and then will be subtracted. So this is the result. This is the bugging in the Java floating point calculations. I will talk about these kinds of problems when we talk about later about big decimal class in the Java Foundations course. But for the moment, you can deal with this like using formatting point.toF, print f, and this will work better like this. And now the rounding errors will not be the problem. Okay, so the next are the multiplying numbers operator, asterisk, and also the division. Multiplying is nothing, it's not much interesting. So if we have int a equals 5 and b 7, if we multiply them, we'll will obtain their product 35. We store this in double, so it's 35.0. If we store this in int, it will work, but it's more correct to hold this in long, because if these ints are big, they will not, the result may overflow the sum. So if we have numbers like this, and if we use sum, the result might be incorrect, like this one. This is due to overflow, but we'll talk about overflows maybe later. And to achieve the correct result, we can do like this. We first go to long, then multiply, and the result is long, and now the result is correct. Okay, and division operator is always integral division, which means, for example, 25, if we divide it by 4, d equals to a divided by b. Okay, so this is how this works. 6 by 4, 6 multiplied by 4 is 24. Okay, but it's 25 divided by 4. This is the so-called integral division. But if one of the arguments is double, the result will also be a double, and this will be floating point division. So division might be integral when we divide int by int, and floating point when we divide, this is an integral division, and when we divide by floating points like this, when we divide by 4.0, it will be 6.25. And also I should mention that in integral division, if we divide by 0, we'll get an exception. It's called, sorry, it's double, but in int, this is divide by 0 exception, arithmetic exception, which says divide by 0. And if we have floating point numbers, for example 25, and we have a floating point division, we'll have, if it is normal, we'll have the result. But if we divide by 0, we'll receive a special number called infinity. And infinity is very special because if we multiply, for example, d equals to d plus 1, infinity plus 1, and infinity multiplied by 5 is the infinity itself. So this is how this works. Infinity plus 1 is also infinity, because if we have infinite number of apples, for example, and we want one more apple, it will still be the infinity. This is how the abstract number infinity works. So we may have also not a number. If we divide 0 by 0, it will be a special constant called not a number or invalid number. So double works differently. It always succeeds when you have arithmetic operations, but sometimes the result is infinity, minus infinity, or not a number. Okay, so be careful. Finally, I'll talk about the most complex, maybe, arithmetic operator called percentage or module or remainder. It calculates the remainder from integer division. I'll show you how this works. If we divide 7 by 2, we have 7 to divide by 2 is 3, and 1 as a remainder, because 3 multiplied by 2 is 6, and 6 plus this 1 remainder gives the source number 7. So this is how the module works in mathematics, in integral computations. So the module here is 1. This is the remainder, the remainder from the division. And 7 is 3 multiplied by 2. 2 times the result is 2. the division result, and the remainder is 1, and 3 multiplied by 2, 6 plus 1 is equal to 7. Similarly, if we divide 37 by 10, the result will be 3, because it's 3 times 10 plus 7, and this is 37. So this is the remainder, and this is the result from the division. Let's say D. And I already explained how this works. 4% is 0 because there is no divider. 4 can be directly divided by 2. And this can work also with floating point numbers. If we divide 3.5 by 1, we'll have 3 and 0.5 is a remainder. So let me show you how this works. If we have int num equals to 15 or 157, we can divide num %10. This will be the last digit because it will be 15, the integral part, plus 7, the module, the remainder part. Okay, so this is how this last calculates. And if we have one, for example, 3.5 or maybe 7 divided 7 divided by 2 will be this, but 7.5 will be, the remainder will be 1.5. And if we divide by non-integral volume, okay, it might work differently, but yeah, that's about the arithmetic operators. You can play with them during the exercises. Let's talk about expressions in Java. Expressions are calculations which include values, operators, function calls, brackets, and other elements that evaluate to certain value. For example, we can have an expression like this: int y equals to x plus 5, for example, and this is an expression which is a kind of calculation, like in mathematics we have expressions like 5 plus 7 or 1 divided to brackets 1 plus 7. So we can consider that expressions are sequences of operators, literals, and variables which are evaluated to a value. Literals are sequences of characters that express certain value. So we have string literals, we have number literals, integer literals, and others. So expressions consist of at least one operand or value or something, and can use one or more operators which combine the operands. For example, this expression is the right part is a calculation, and this part here is an assignment. So we have we have here an expression, and we have here an assignment, and here we have a variable declaration. So this statement here, it's a combination of many things: of assignment, of declaration of variable, and of expression, calculation of expression. So this is another kind of expression, shown though in quotes. It's an expression of type string. This is a string, and this is an expression of type int. It is integer, and we may have expressions of different types. For example, an expression of type student, for example. So this is another example of expression which includes brackets, some operators, some operands, and literals. So literals are things like this: 150. This is an integer literal. This is a string literal. This is a variable, and this combination of brackets, literals, operators, variables, function calls, etc. This is called expression. So we use expressions to perform calculations in Java and in programming in general. So let me show you some examples. I will run my IntelliJ IDEA because I stopped it, and I will open my last project just to type some expressions to you and to give you more details. So where is my IntelliJ IDEA? It's still starting. Oh, it is here. So if I have, for example, double, for example, x equals 5.3, and I can have, for example, print x divided by 2. This is an expression. So it will first make this calculation and later it will print it. But I can have a more complex calculation like x plus 1 divided by 2. This is another expression. The return type here is double. If I have var result equals to this one, and if I print the result, this result will be of type double. Why? Because the expression is of type double. So we can do this, and I can even change the type of this expression. So this is an operator to change the type. I have in brackets the new type, and I can change the type between numbers and between some other, let's say, compatible types. Okay, so expressions have a type. For example, if I have hello plus this expression, this part is double, but this part is string, and when we combine string with double, the result will be string. Now result is of type string. It is var, which means that take the type from the last part, and this is how expressions work. They can also include some function calls, like math.sqrt. Please calculate a square root of x plus 1 divided by 2. This is something like this one. X plus 1 divided by 2. This is a mathematical expression. And plus hello. And now when I run this, I'll have another result. This is the calculated expression. So this is how expressions work in general. Now it's time for the hands-on exercises, because we want to learn skills, not just talk or watch video lessons. Follow the exercises, solve the practical problems, and send your solutions to the Judge system for automated grading. You will find the problem descriptions and the link to the Judge in the lesson materials and slides which we publish at softuni.org. Let's do the exercises, let's code, let's solve some practical problems. It's important that you learn by doing. To learn coding, you need to write code. No other way. Write code, run the code, test the code, make mistakes, fix the mistakes, run the code again, test again, find other mistakes, and repeat until you are ready. Finally, submit your code in the Judge. Maybe it will have other mistakes or not. Resubmit it, fix them, etc., etc., etc. This is how you learn coding, by practice, by coding. The only way to learn coding is by coding. So watching videos gives you only knowledge, not skills. To learn skills, you should practice. Watching videos how someone is skiing, for example, cannot allow you to learn how to ski. It's skill, it's not knowledge. The same is with math, with programming, and many others. So solving the hands-on exercises with these lessons gives you the experience and practical skills. You should write code, you should solve exercises, and our training courses are designed to acquire skills and to get a job someday. So write and submit the coding exercises. Let's start with the first exercise. It's about writing a program to convert from US dollars to euro at a fixed rate. So we first read the floating point number, the dollars to be converted, then we convert the dollars to euro by a fixed rate of 0.88, and we finally print the converted value in euro formatted to the second digit after the decimal point. So this is an example. We have 17, we multiply it by 0.88, and the result is this one. This is another example. Okay, let's solve this. I will open the IntelliJ IDEA. First, let me find it. Where is it? Okay, and I'll create a new class which will be called USD to Euro. USD to Euro. For example, this is a good name for this class because it answers the question what inside. So we create the static void main, and we first create a scanner which will be used to read our input. It is new scanner of system.in. Then I will read the dollars, something like double dollars equals to scanner.next double. Next double, and I need to fix this. Then I will calculate the euro. Euro as the dollars multiplied by 0.88. We assume the rate is fixed because we still don't know how to implement a web service call request to take the real rate from somewhere, and we just print this euro. And when I start this with right click and run, I can say that for 70 is 14.96. I have the judge system, and I can use this judge system to submit my code. And this is what you are invited to do. Copy this code or Control C and paste it here, Control V. And I click submit. It takes some time. I refresh. Maybe I wait a little bit more, and looks like it doesn't work correctly. I don't know why, but maybe I forgot to this 2 digits after the decimal point. So I should have printf of %.2f and with a new line at the end, and this is my my solution, which is improved. And if I have some wrong number, the output will be formatted up to 2 digits after the decimal point. Okay, now I will submit again, Control V, submit, and after a few seconds I will refresh. Now my solution is correct. It has passed successfully all these 5 tests which are put in the judge. Okay, let's continue with the next problem. This is just a solution. It's called for operations. We need to write a program which reads 2 real numbers from the console and performs 4 arithmetic operations on these 2 numbers in the following order: plus, minus, multiplication, division, and the output should be like this. If we have 5 and 10, we should print 5 plus 10 equals 15. 5 minus 10 equals minus 5. So we always use 2 decimal points after the decimal, two digits after the decimal point, and that's all. It's not quite complex. In fact, I can clone this solution like this: Control C, Control V, and I copy the entire class because this problem is similar to the previous one, but the name is for operations, okay? And I have another class called for operations. I have already the scanner, and I will have the first number, which is 8, A, for example. The second is B, or maybe I use better num1 and num2, and I can print something like num1 plus num2 equals to some other number, and something like num1 and num2 and the sum num1 plus num2. Okay, let's see whether this works correctly or not. I'll run this, and if I have 5 plus 10, 5 plus 10 equals 15. Works correctly, and I need to implement the other operations the same way. So if I have minus, I'll have minus here as well. If I have multiply, I'll have the multiply here as well. And if I have division here, I'll have division here. And let me check whether this works or not. 5 and 10. Looks like this is similar to this. So I can open the Judge and submit my code just to check whether it is correct or it's not. Copy, and I go here, I put paste, and I submit it. Submission is sent, and I will wait a bit. Looks like it's correct. So we can continue with the next solution. This is the same thing which I already wrote the code. So we go to the next problem. The next problem is called market, and it works, it's as follows. A farmer sells tomatoes and cucumbers at the market, the fruit market. So you need to write a Java program to calculate the total cost of the farmer's production by given quantities and prices. So we are given the following: how much the tomato costs, the price of tomatoes, the quantity of tomatoes, the cucumbers price, and the cucumber quantity. So if we multiply this, and we also multiply this, if we multiply the tomato price by the quantity, we will find how many dollars the tomato costs, and the cucumbers the same way. And if we sum this, we'll find the total cost. Okay, so this is an example. So if we multiply these two numbers, and we multiply these two numbers, and we sum these two outputs, we'll find this. So this is the multiplication of these two. The second is the multiplication of these two. And the sum is the sum of these two above. Looks quite easy. I will again copy these four operations. Control C, Control V. I click on the left, on the class name, and now I will give a name, market, because this is the solution of the market problem. I read the tomato price and the tomato quantity. Then I will copy these two ones, and we'll have cucumber price. Oh, it's wrongly written. Okay, and I will have something like var tomato cost equals to tomato price multiplied by tomato quantity, and cucumber cost equals to cucumber price multiplied by cucumber quantity, and total cost equals to tomato cost plus cucumber cost. And finally, I need to print it just to check in which format I should print it. Oh, I should print something like this. 140. Okay, the first I should print. I can print like this. Print the price, tomato cost, plus the plus sign. And in the same way, plus the cucumber cost equals to, and finally I print the total cost. Because I want to print the tomato cost and the sign plus, then this cucumber cost followed by the sign equals, and then the final sum. And they should be formatted with 2 points after the decimal, two decimal digits after the decimal point. So I will use print f, and we'll have something like %.2f plus tomato cost. Looks like I need to rewrite my code, and this is quite normal. Sometimes we write the code and we find a mistake and we fix the mistake. It's quite normal process when you are coding. Equals, maybe I forgot the new line here, %n, and and this is the total cost. And let me check whether this works or not. If I'll take this example, 42.5, then 3.30, then 60.8, and then 1.80, and I have 140.25, 109.44 equals equals to total cost. Looks like we need to do this again. I will copy this because I don't want to type it again. Enter. 249.69. Looks correct. And now I can go in the Judge, open the third problem market and submit it like this. It takes some time for processing, but my solution is correct. Okay, I solved the market assignment, and let's go to the next. This is a sample solution which is quite similar to what I already demonstrated. And the next problem is called tiles. Tiles, we have a rectangular bathroom like this one, and we want to cover it by tiles. Tiles are smaller than the bathroom. You know, because you have a bathroom at home, and it's usually covered by tiles, and these tiles are arranged one to another, and we want to cover types of smaller size. For example, if this is 5 by 2 meters, it's 10 meters, for example, and this is 0.3 by 0.4. This is the size of the tile. Okay, so we want to calculate how many tiles we'll need to do this covering and we usually add a 10% extra tiles surplus, and we want to round to the nearest integer, because if we want to go at the store, we want to tell the seller how many tiles we need. So we usually need enough tiles to cover this, plus some surplus, because some tiles can be broken, or you always need more tiles than required to have something as a reserve, as an additional availability. Okay, so how to calculate this? If we calculate the area, and if we calculate the tile size, and if we multiply the area plus 10%, or we multiply, which is multiplied by 1.10, okay, we will calculate the area. It's given here. So the area of the bathroom is 3.3 meters by 2.2 meters, which its area is 7.26. When we add 10% surplus, we'll get 7.986 square meters. Let's assume it's meters. It could be inches or foot or something else, but square meters works well. And the tile area is when we multiply these two. This is the tile area. And when we divide this area to the tile area, we'll get how many tiles we'll need. We'll need 42.592, and we need to round this up. How to round this up is something we didn't learn. So you can search it in the internet. I will not solve this problem because I want to leave it for you, but I'll give you some hints so you can read the room width and height, and we can multiply them to calculate the room area. In the similar way, you can read and calculate the tile area. And when you multiply the room area by 1.1, this is the area plus additional reserve of 10%. And when you divide this to the tile area, you will find exactly how many tiles you will need, but this will be a floating point number. It will not be an integer. So you can round up like this. It's rounded, not up, but for example, if it is 35.1, it will be 35. If it is 35.5, it will be 36. If it is 35.83, it will be also 36. This is called in mathematics rounding, and this is the natural rounding of the numbers. Okay, so this is how we can round numbers. Another way is to go in Google and to look at this. For example, I can open a new tab and write Java round double to int. And in Stack Overflow, you can see that the answer might be like this. math.round, there is a built-in method, and you should then cast to int. Another way is what I have used. I add 0.5 and then truncate to the only the integral part, the int part. And there are some other solutions which are quite different, but math.round works well. And there are some other solutions, etc., etc., etc. You can open some kind of other solutions, etc., etc. math.round. So this is how it can work. Okay, so this is the final problem for you, and I highly recommend that you solve this problem and yourself without just copy paste my code. And also I highly recommend that you submit it in the judge, and if you open the results you should have 400 for 100 points for each of the problems. Okay, so remember that the most important activity in learning how to code is the coding. If you don't code, you will not have skills. If you just watch these videos, you will get some information, but you will not have the skills. For example, to learn how to drive a car, you should drive a car. You should first learn some theory, but then you should practice. It's the same with programming. So maybe I repeated myself several times, but it is tremendously important to do and submit your exercises and to practice what you have learned today, to develop it as a skill, not just as a theory. So do your exercises. Did you like this code lesson? Do you want more? Join the learners community at softuni.org. Subscribe to my YouTube channel to get more free videos, tutorials on computer programming, Java, software engineering, and many others. Get free access to the practical coding exercises and the automated judge system for these code lessons to evaluate your code from the exercises you write. Get help from the mentors and meet other learners. We will answer your questions. And it's all free, completely free. So join now.